I don't know about you guys, but I'm very excited to start FBA Lab with you all. So if you have reached till this point, I'm sure that you have requested access to FBA Lab by visiting bubblenet.com /lab/speedrun, and you have requested for access. You have got the access. You have made the payment, and you are ready to start with FBA Lab. Before I go further on how to take first steps with the FBA Lab, let's look at certain aspects. So the first thing that we look at is events. So FBA Lab is going to have a lot of events. For example, the current run, we have the first event called a first break speedrun, right? So this is the event that is going on, and very excited to take you through this event. Once this event ends, there'll be other events, and the steps will remain the same. So once you have access to FBA Lab, you can go to Speedrun. This is the Speedrun homepage, and you are going to see this event card here. If you joined the event, this is how the card looks like. So you have your journey where you can start, and you can see the cohort standings. We are in the process of improving cohort standings and how to score. So you will see a lot of changes and very interesting things around gamification, right? So for example, you can see every particular part of FBA Lab is gamified, helps you get engaged with the content and makes your journey very exciting. So you can click on start with welcome, or you can go down and restart from the first step. That's your choice. Once you are on this page and you are on this page for the first time, and if an event is live, right? If a new event is live, you can join that event. So you will see something like this. When you are on this page, all the events will be listed. And for example, if you have not joined a particular event, like if you have not joined First Break Speedrun August 2026, you can click on join event and you'll be able to join the event, right? So first of all, what is the structure of FBA Lab? FBA Lab is very cleanly divided into two major parts, right? So one is, and this is all for study mode. There will be two modes. One is study mode, and we'll have a GPU mode coming in future. But for study mode, there are two major parts. The first part is that there is content on every page, right? So to start, you can click on start with welcome. You'll be taken to a page, and you can click on the next beat and keep progressing further. So on every beat of this journey, you will have content. Like you can go down and you can watch a video. So this video will be uploaded on this page in a short time. You can read the content, and very important, there is a go deeper with Rune. So Rune is our AI assistant, our AI tutor, which will be evolving as we move forward. But there are additional things on this particular section, right? And what are these additional things? There are two kinds of things that you can see over here. One is additional content, and the second thing is a challenge, right? There'll be challenge and there'll be content. Now, what we do in FBA Lab is our aim is to increase our fluency on particular topics. For example, you want to increase your fluency in PyTorch or in LLM modeling, and in that there are several subtopics like optimizers, could be loss function, could be any other aspect. Then there could be other tools and areas where you can increase your fluency. So this particular beat allows you to increase your fluency in LLM modeling, basically optimizers and PyTorch. Now, there are two ways to do it. One is the mandatory way, that you can go ahead, watch the lesson, complete, read whatever is given over here, and ensure that you have understood everything, right? And move on with the rest of the task. Or you can do another thing is you can go to, sorry, lost my train of thoughts. So that will give you, so the first step is you can watch the video and you can read the primary article, right? Primary content over here. And the content is not just the text. There is huge amount of visualization that is available. So there are blocks here, there is code blocks, code visualization, and then there'll be a article below. So that's just the basic thing. And you can mark this complete, this particular beat complete. That's a self-marking sort of this thing. Of course, everything is going to be validated either over here or on Discord server. So you have to join the Discord server, mandatory. And you go back. So either you read the content. The second part is how to increase fluency in these two areas. That's our goal. So for that, you have to go deeper with Rune and increase your fluency by reading the article and by clicking on the challenge and completing that challenge, right? So every challenge that you complete and every additional article that you read, you will get fluency points. So once you open this, you can read the challenge and you can give your answer. You can attach files over here and admin will judge your answers and either give you three things, either pass, fail, or re-challenge, right? You can also submit challenge via Discord server, but you have to submit the challenge 1-to-1. So you have to basically ping the cohort leader, which is, you can ping on my ID, or you can generally ask for it on Discord. So both ways are there, but this is functional. You can push your answers here, right? So this is one way. So as you move forward, your fluency will increase, and you will see your fluency points here. Right now, as you can see, I have not submitted anything, so my fluency points aren't there. So you can keep on going forward, and then at the end of the cohort or at the end of the event, you will have certain fluency points. This is going to impact your certificate. So this allows you to map what you have learned with this. So for example, your fluency and your detailed fluency areas will be mentioned on certificate, and you can even see a detailed web certificate is required. So these are the main parts of FBA Lab and how to go about it, right? Welcome to FBA Lab. The first event is live. Make sure that you join the event. Make sure that you join the Discord server, very critical. And hopefully we can move ahead with the rest of the things. Yeah, just a moment. So this is about the overall structure on how to move about and how to do things, right? Now let's get to the core area. We are basically going to learn about Speedrun. We are going to use Speedrun as a base, but learn LLM training and inference as a skill, right? So there are three acts to this. The first act is model training fundamental. Then there is optimization, where you basically read the training logs, you see the diagrams and everything. And third part is you basically do the actual speedrun. You take around 6 or 8 speedrun experiments and iterate. So you can read the code, you can look at intuition and everything, and understand what decisions are taken. So this is simulation or study mode. You can look at what is being explained here, and there'll be challenges and tasks, and you can complete those tasks by actually doing speedrun at your local laptop using Model or any other GPU. So this is an example of speedrun where there's a baseline script and it takes certain steps to reach the baseline script, and you can see that we can reach those steps faster. That is the target loss faster. So with every, and whatever these clicks are, these are basically changes in the architecture. So with baseline, we have certain architecture, and then we make changes to the architecture. We add like position information of tokens, makes the model better, faster. We go to, we change the optimizer, make the model faster. We also do some other changes like soft cap or changes with QK norm, makes it faster. And then the last one is we look at context and we add skip connections. Also, there are changes with attention that are done, so that makes it faster. So these are like the 5-6 steps, right? And we'll be going through all of them. This is Act 1, where we look at a very small part of speedrun and we look at how these 6 decisions were done. This allows us to understand a lot of skills. So you will get a lot of fluency about AI. You will be able to master certain core aspects of AI. And the example that I had given was, one of the things was modeling, PyTorch, and other areas. So this chart will grow, you keep on growing. So this is the first step. Let's look at the first lesson. Basically, what we are here to build is LLM training and systems engineering. So we want to be able to actually train a model, but only training is not the idea. We also want to understand the skill to unpack these models, make changes, start a training run again, right? That's the idea. So we look at Speedrun, but we will also go deeper and look at actual tech reports and papers and everything and tie it back to Speedrun. It's a pretty cool experiment as a base, right? So for this, we are going to use distributed training, which means we are going to use more than one GPU. In this case, we are going to use 8 GPUs. Now, the core idea is pretty simple. We are going to, let me increase the size a bit. So we are going to use 8 GPUs. We are going to number them from 0 to 7 and call it rank. So this is rank 0 GPU, rank 1, rank 2, rank 3, and we have around, the last one as rank 7, right? So 8 GPUs. Now, why do we need 8 GPUs? Because we have a data set and we can use one GPU and we can pass on chunks, data set pieces so we can load the GPU with the model. We can pass data set to it, update the model, pass the second batch, update the model, but it will be a single batch at a time. That's a long process. A simple idea: split data into 8 pieces, load the same model on all 8 GPUs, and pass batches to, so divide your, basically you will have 8 batches at a time and simultaneously train those models, and then move to the next batch, till you are done with the training. So the idea is pretty simple. Now, what we have to think about is that how are these GPUs connected? What is the communication between these GPUs, right? So for this, there is a blog that I had written, which is referred here. I hope it opens up. Yeah, so this is the blog, right? So this is basically a learner script, and you will get similar scripts from everywhere. It tells you what DDP does, right, at a base level. So we talk of only 2 GPUs and how on every, so there'll be a forward pass in which basically we are going to move from the input side to the output part of the model. And if you remember the Quen 3 lecture, which is the basic pre-work required for this course, you would know how the structure looks like. How the first intuition was that a model is a stack of blocks, So we move with forward pass, we move from the left to the right, if you can imagine that, a model in that manner. And as we go forward, we accumulate gradient. So what we are going to do is, we are going to calculate loss, right? And once we calculate loss, we will, in backward pass, get gradients. There will be a forward pass. Then we'll calculate the gradients. What are gradients? How are they calculated? How are they stored? Is part of the first beat. So this is the welcome beat, but officially first beat. We'll talk about that, right? There'll be other things as well. The basic idea is the same, that you are at rank 0, then you have a forward pass, then there is a loss function calculated, gradients are accumulated. Then you do something called as all reduce. All reduce will take gradients from here, gradients from here, and if there are 7 GPUs from everywhere, and every rank will get a sum of all gradients, and then you will divide, right? So, and then you will use the optimizer to update the model. Pretty simple. So you do a forward pass, calculate loss, accumulate gradients, then you do communication. And communication is all reduced. Now, since we have already spoken of communication and other things, now you can ask this question again, that what is the topology and how are these GPUs connected. Is GPU 0 connected to everyone, or are all GPUs connected to each other? So we can think of two basic topologies, ring and mesh. In mesh, any GPU can talk to any GPU. In ring, basically you talk to your neighbor, right? So it is more efficient to talk to the neighbor because our goal here is to just accumulate the gradients from all GPUs, right? So so first of all, we are doing distributed data parallelism because data is being distributed, and it's a parallelism technique to get that efficiency through, right? If we think about it in terms of dimensions or axes, we can call this as 1D, one dimension, right? Because only data is being parallelized. So we are basically saying we are using a ring topology rather than a star or a mesh. So every GPU holds a full copy of the model and only batches split across the ranks. After each backward pass, all reduce to average the gradient, which we have discussed. So this is part of the communication because these GPUs are like connected via two protocols, but the communication protocol is NCCL, right? So they're connected via NVLink. So when you actually spin the GPU, you won't spin a single GPU, you will spin 8 GPUs. And what is the communication protocol and how are they arranged will be given by the cloud provider. This is the way it will work, right? So full mesh, all reduce. Full mesh basically means NVLink NVSwitch is on every GPU, can talk to every GPU on full bandwidth. There is no cable topology forcing traffic, so you don't have to like go through one GPU. And NCCL collectively walks gradients around a ring. So this can also be thought of as a tree with the last branch sort of connected. So what happened? Sorry. With the last branch connected back to the first one, right? So the connected ring. Again, master is not hub. That's not a important point. So this is entry level move at, as models and clusters get bigger and we'll have 2D, 3D and 4D level of parallelism. This is DDP, but we'll get that complexity. So where is that complexity given? Here is how one training run actually moves across 8 GPUs. So this is giving how the branch, the initial pre-forward pass, how batches are split into micro batches. Then there is forward pass, then there is backward pass, and then there is an all reduce or sync gradient step. Then there is an optimizer step, which is our goal to actually improve the model. And then we repeat to the next batch, right? So this pattern never changes. Look at this pattern, these 5-6 steps. We will think of every 2D, 3D or 4D technique via this thought process, right? Now we go more into detail. What is all reduce? And we have given a code on how all reduce works. So if you're using standard PyTorch, you will use this all reduce and pass the gradients and we'll pass the op. So we are basically just summing here because we are going to divide by world size. And the idea is pretty simple. If you do this, once you collect the gradients and you divide by the world size, you sum and you average it, you are basically averaging the gradients or the changes across all 8 GPUs. And that's the idea here, right? So there is more information here. We stop here because we want to think about, which will come in future. We will look at the code, how the scripts are there. So one thing very clearly should be mentioned over here is that there are, as I said, there are 3 acts. So let's look at Act 1 and Act 2 only. Act 1 and Act 3 only. And we will not think much about Act 2 for now. It will sort of be included inside, right? So Act 1 is basically, if I have to say, Act 1 is basically a simple speedrun project. Act 3 is basically the real speedrun project, right? So if I go to, it's not better to go to, yeah. So anyway, here I was trying to like work on something. can even close this or minimize. So let me just push this to the right side. This goes below. All cool. So this is the structure of the project. So this project is called as So this is the project. So this is the project DDP training. So there is a base script which you can refer to, or you can use any other script from YouTube, GitHub, doesn't matter. Base DDP script, right? But what are the other two projects? One is Modern NanoGPT, which is the actual speedrun. And this is a small script by Tyler Romero. And we are basically focusing on this part itself. Instead of looking from here, I will actually focus on the ID itself. So we are on cursor, and this is the project structure on the left hand side. I'm not sure if it's visible because the recording is not telling me where the... Okay, so maybe it's not visible. What can I do to make it visible? Either I can change... move this. Oops. Okay, that made sense. Yeah. Getting into... Okay, I think it's visible. Yeah. Now the whole screen is in my recording zone, right? That's good. So we go to DDP training, and this is the path. So I have mentioned there are 3 projects here. The first project is the basic DDP, which is at the home root location. But there are other 2. One is NanoGPT Speedrun, the mini project that I'm talking about, and Moderate GPT, the big one. So when you look at the mini project, there are these iterations that we are looking at. The original, the NanoGPT Speedrun will have around 80 odd iterations. So we'll look at 6 or 7 of those also. So the script here is pretty simple, and the script for the actual speedrun becomes complex, right? So there are more decisions, but everything is in 1D. So we are going to go beyond 1D after a point, but here we will only look at DDP for now, right? Maybe in more advanced part we look at 2D, 3D, other areas. Right now our focus is 1D and looking at the model. So the takeaway is that the Act 1 is basically where we look at the smaller code. The code is not small, it's just that it's a simpler script. And this is a bit more complex, right? That's it. So that's the idea here. We have done the first part. As I said that you can enroll in the event, go to the event, go at the bottom. Once you're there, where is it? Yeah, here is it. Go to this particular section, find Go Deeper with Rune, click on it, submit the challenge. Here we are asking you to submit a basic shape. What is your understanding of GPT? And you can give your explanation here. Try to give detailed explanation that you understand. Attach a diagram or of your understanding, and that's your first step. First step is simple. Just go through this video, then complete this particular challenge. That's your step 1. Then we'll think about step 2. Thank you all. Welcome to this event, and let's learn and let's have a lot of fun. And let's build cool things. So see you in the next beat. Till then, bye.